Hey guys, and welcome back to another video on my YouTube channel. Today's video is all about arcs and sectors. So let's get started. Before we jump onto the calculation parts, I'd first like to explain what exactly are arcs and sectors. An arc is a section of the edge of a circle. When you pick 2 points on the circle's circumference, it forms 2 arcs. The shorter one is called the minor arc, as I'm showing you here, and the longer one is called the major arc, as shown here. A sector is the section of a circle that's bounded by 2 radii and the arc between them. 2 radii in a circle divided into 2 sectors. The smaller one is called the minor sector, as I'm showing you here, while the larger one is called the major sector, as shown here. Also, the word radii is simply the plural for radius. You can imagine a sector like a slice of a round pizza, with the arc being the curved crust along the edge of the slice. I'm showing you here the formulae for arc length and sector area. As you can see, arc length equals to the angle theta over 360 multiplied by 2 pi r. The sector area equals to the angle theta over 360 multiplied by pi r squared. Note that these formulae apply to the minor arc here, as theta is the angle for the minor arc. If we were calculating for the major arc or any other arc present, we would use its respective angle in place of theta and apply the formulae as normal. Here's an example. In this example, we have to find the arc length and sector area of the sector AOB. We already know the formula for arc length is theta over 360 multiplied by 2 pi r. So all we need to do now is substitute the values in the formula. 55 degrees for theta and 5 for radius, which is r. Then, enter 55 by 360 multiplied by 2 into pi into 5 into your calculator and press the equals to button. As you can see, the answer is pretty long, so we are going to take it to 3 significant figures. Therefore, our answer is 4.80 centimeters. Now to find the sector area. We know the formula is theta over 360 into pi r squared. So we are simply going to substitute 55 degrees for theta and 5 for the radius, which is r. By inputting 55 over 360 multiplied by pi into 5 squared into your calculator, we get a large answer as shown here. So by rounding it to 3 significant figures, we get that our answer is 12.0 centimeters squared. Here's another example. We have to find the radius and length of sector XY. We have the sector area already given as 50 centimeters squared. Let's start by finding the radius. To do that, let's review the information we are given in the question. Since we are given the sector area, we can use the formula for the sector area to find the radius. Simply substitute 50 for the sector area and 60 for theta. Now solve for r, the radius. Divide both sides by 60 over 360 into pi. Then take the square root of both sides. Entering all that into your calculator and pressing the equals to button, you will get a large value. So, we are going to round it to 3 significant figures, giving us the value for radius as 9.77 centimeters. Now to solve for the arc length of the arc XY. We simply substitute the values into the arc length formula. 60 for theta and the value of the radius we just found for r. However, we will not use the rounded value. We will use the longer value. Input 60 over 360 into 2 into pi into the longer value of the radius into your calculator and press the equals to button to get the answer. One way to enter the long value of the radius into your calculator is to press the answer button on your calculator for it when calculating for the arc length of arc XY. This will work if the long radius value was the last value before you press the equals to button. Also, the answer button usually has the letters A, N, and S written on it. Moving back to our answer, again, we have a pretty long value. So, rounding it to 3 significant figures, we get 10.2 centimeters as our final answer. Thanks for watching. Please like and subscribe. I'll be back with another video soon.